Okay, well, let's talk about section 5.3. We're solving equations with radicals in them, all right? And so our first problem here simply says radical x plus 3 equals 12. Well, and we're going to approach this just like the very first day we started solving equations. We're going to subtract 3 from both sides, and we're going to come up with radical x equals 9. Well, then how do I get radical x to become just a plain old x? Well, because this is the square root, which could also be written as x to the 1/2 power, then squaring it, which means 1/2 times 2 over 1, gives you 2 over 2, or just x to the 1st power, or an x. So how do you cancel out a square root? You square. They're inverses of each other. And of course, then we have to square this side, and so we come up with x equals 81. All right, let's check that out. What happens when I put 81 in here? What's the square root of 81? 9. 9 plus 3 equals 12? Yes, it does. All right, so squaring a square root gives you just the plain old x that you're looking for. All right. Sometimes it's a little more, it's not really complicated, but sometimes there's a few more steps. Here, I want to get rid of this 7. And so I'll subtract 7 from both sides. That would be what? Negative 13. And I don't want a negative out here. I want this to just be a plain old radical x minus 4. And so essentially, what am I going to do? I'm going to divide by negative 1 because that cancels the negatives out. And now I have the square root of x minus 4 equals positive 13 because a negative divided by a negative is a positive. Now I will square both sides, and that will leave me with x minus 4 equals 169. One last step, x equals 173. And if we check this out, if we put the 173 here, that's the 169. What's the square root of 169? Well, it's 13. 7 minus 13 is negative 6. It works. It checks out. When we start to use squaring to solve equations, it is imperative that we check our answer, okay? Because sometimes you can get an answer that is just a little bit extra. We don't call it extra. We call it extraneous, all right? But it means extra. All right, so you always need to be looking for extraneous solutions when we start to solve radical equations. All right, hey, it's not always a square root that you're dealing with. Sometimes it can be a cube root. So here we would subtract 1, and that would give us the cube root of x equals negative 3. How do you cancel out a cube root? You cube it. All right, so the same way that a squaring cancels out a square root, cubing cancels out cube roots and leaves us with x equals negative 27. Negative 3 times negative 3 times negative 3 is negative 27. If we plug that in, just to check it out a little bit, what's the cube root of negative 27? Well, it's negative 3. Plus 1, yep, that equals negative 2. It's not extra. It's the correct solution. It's not extraneous. All right? Now then, here's a multi-step one. Let's subtract 7 first. Then we'll be left with this equals 8. Okay? That's a little bit long there. Don't need it to be that long. Now we're going to divide by negative 2. And what do we have left? The cube root of 2x plus 5 equals negative 4. How do we cancel out a cube root? We cube. All right? So then we're going to have just the 2x plus 5, because this canceled out that, equals, what's negative 4 cubed? Negative 4 times negative 4 is 16, times negative 4 is negative 64. Then we will subtract 5. We'll get negative 69. We'll divide by 2. And we'll get x equals negative 34. And yes, you should go back and check to make sure that it all works out. All right? I'll let you do that. I think it's going to be okay, though. All righty. Now, there's no radical. All right? There's just an exponent. All right? And the exponent is 5/3. When I'm done here, I want that exponent to be 1. I want it to be x to the first power. So, what would happen if I took 5/3 times 3/5? Doesn't that give me x to the 15 over 15 power, which is the same thing as first power, which I really don't even need to write. It's just going to be x. Yep. And so taking this to the 3/5 power. Now remember, 3/5 power means cube it, take the 5th root. Well, I happen to know that the 5th root of 243 is 3. 3 times 3 is 9, times 3 is 27, times 3 is 81, times 3 is 243. So I can simply, this is simply 3 to the 3rd power, because the 5th root of 243 is 3. Now, I know that by memory. I've been a math teacher for approximately, I don't know, 40-some years. Maybe, no, 30 years, okay? And math classes for about 35. So, I know that. You don't know that, you better have your calculator handy to help you, all right? And then I know that 3 cubed is 27. X equals 27. So sometimes you just need to multiply by the reciprocal of the exponent to make the exponents cancel out. So we're going to do that here, but we're not going to do it until we get rid of this 3. And then we'll have 2x plus 12 to the 2/3 power equals 16. What if I multiply this by the 3/2 power? That's going to cancel everything out and just leave me with 2x plus 12, isn't it? Yes, and that's what I want. Oh, by the way, do you know what the square root of 16 is? That's 4. What's 4 cubed? That's 64. And now we've got 2 steps left. Subtract 12. That's 52. Divide by 2. That's 26. Do we have to check this answer out to see if it's extra? Yes, we do. Okay? And we'll go up there. Usually when you're getting one answer, you're okay. It's when you start to get more than one that you got to be worried. Okay? Uh-oh. What do we have here? We have square roots on both sides. But hey, that's kind of cool, because if I squared that, it would go away. And if I squared this, it would go away. Oh, that's just x minus 3 equals 2x minus 7. I'll subtract x. That'll leave me with negative 3 equals 1x minus 7. Add 7 to both sides, and we come up with 4 as our answer. Okay? So yes, sometimes you may have to square both sides to get it to work out. Here's the last one, and this one is a little bit tougher. And it's tougher because of this one right here. Okay? I'm still going to square both sides, and that's going to give me a 2x plus 3 over here. But when I square both sides here, that means I have to take 1 plus radical x plus 1 times 1 plus radical x plus 1. All right? And so now I've got to do the FOIL method. 1 times 1 is 1. 1 times radical, that just gives me the radical x plus 1. That gives me another radical x plus 1. And then when you take radical x plus 1 times radical x plus 1, you get x plus 1. Okay? So, let's see, we can combine some things here. There's a 1 and a 1, so that becomes a 2. All right? And actually, I'm going to rewrite. I'm going to wait and put that at the end. I'm going to put the x first. And then I've got 2 of these, and then a plus 2. All right? So I still have a radical involved. All right? Well, I want to get that radical by itself. So what do I need to do? Well, the first name, let's subtract x from both sides. And let's subtract 2 from both sides. Let's see what that gives us. That's going to give us an x plus a 1. And then the only thing over here is 2 times radical x plus 1. I want to get rid of that 2. And so I'm going to divide by 2. And that gives me x plus 1 over 2 equals radical x plus 1. Why do you think I wanted to get that radical all by itself? Well, I'll give you a hint. It's because I want to square it, because if I square it, I'll get rid of it. And you say, but we already squared once. I said, you're right, we did already square once. We're going to have to do the squaring thing twice in this problem. Why? All because of this little punk right there, all right? That was what messed it all up and made it be much longer. So if I square that side, I got to square this side, all right? Well, this is easy. If we square that, we just get x plus 1, right? Now, if I square this, I have to square the top and square the bottom. Well, I can square the bottom. How do I square the top? Well, you take x plus 1 times x plus 1. Now, I know that in my head. That's going to be x squared plus 2x plus 1. Okay? Now, we can, you know what I'm going to do? I'm going to multiply both sides by 4. And that way, I get rid of that fraction. If I multiply this by 4, I get 4x plus 4. Then I'm going to get everything on one side. I'm going to subtract 4x. And I'm going to subtract 4. And that's going to give me x squared minus 2x minus 3 equals 0. And now I'm going to look to see, can we factor this? Are there any factors of 3 that subtract to give me 2? Yes, there are. 3 and 1. And so now I know that's got to be a negative and that's got to be a plus. So what are my answers? Well, the answers are x equals 3 and x equals negative 1. You set those both equal to 0 and solve. Now is when you got to really be aware. One of these might be extra. So let's take 3, go way back up to the top. Let's put a 3 in here. What's 2 times 3? That's 6. Plus 9. What's the square root of 9? Well, that would be 3, wouldn't it? Put 3 in here. What's 3 plus 1? 3 plus 1 is 4. What's the square root of 4? It's 2. 1 plus 2 is 3. So 3 works. All right? Let's see if negative 1 works. Well, let's see. Put a negative 1 in here. You get negative 2 plus 3. That's 1. You get a square root of 1. Right? And you square that. Okay. Now what happens? Well, no. Maybe it's okay. Let's go back. Negative 1 times 2 is negative 2. Plus 3 is 1. Use the square root of 1 is 1. So you get a 1 underneath there. Put a negative 1 in here. Negative 1 plus 1 is 0. What's the square root of 0? 0. 1 plus 0 is 1. Hey, they both work. They are both answers. Whoopsie. They are both answers. Neither one of them is extra. But a word of warning, sometimes they can be extra. All right? Hope that helps. Good luck.